Welcome back here, ladies and gentlemen. We are going to take a look today at our geometry equations unit review for our upcoming test. So, which consists of 12 multiple choice questions followed by 2 open-ended questions. So, this first video we're going to take a look and try to go through everything for the multiple choice part. Okay? Alright, question number 1. Mr. Miyagi teaches karate lessons. Wax on, wax off. He charges $10 per lesson and charges a fixed fee of $45. Which equation could be used to find the number of lessons X for a customer that Mr. Miyagi charged $245 for? So we know it has to equal $245. Okay, like that's how much total charge is. So if I'm looking through my answers here, okay, here it equals $245. That looks good. This doesn't look like this looks good. Part B rather, and part D, they don't make any sense already to begin with because it's not equaling $245. The fixed fee of $45 means that 45 is by itself, okay? And then the $10 per lesson means that every time you have another lesson, you are charging an additional $10. So I'm looking at the two of these left, A and C. The one where 45 is by itself is right here. This makes sense again because every time you have a lesson, it goes up 10, which is your slope in this problem. The 45 is almost like your just your constant, like that's what you pay no matter what. Alright? Okay, number 2. How do you write the solution to a system of equations? Now, there's a lot of good things going on here. Two numbers, y equals mx plus b, x equals y equals. But we always want to write it as an ordered pair. Okay? We spent a lot of time in class going, oh boy, is that supposed to be it? It's a horrible D. There we go. So it's an x comma y. Alright, please be careful about that. Do not, that's an easy question. You guys all know that. You've been doing that for a very long time. Solve for x in the system of equations below. Now, this problem right here, this is a systems, okay? And if we're looking to solve for this, what we could do is, you could try to do elimination method, so on and so forth, if you'd like. Alright, we could also do substitution. So, here's the neat thing. Alright, since they're both equaling y, that means that these two things have to equal each other as well. Alright, so let me show you this off to the side. Negative 2x plus 1 can equal x minus 5. Now we can solve for this. Add 2x over. 1 equals 3x minus 5. Add 5 over. 6 equals 3x. Divide by 3. X equals 2. If that confuses you, we could have multiplied the bottom one through by 2 and gotten 2y equals 2x minus 10. And the top one is y equals 2x, or negative 2x plus 1. And if you go ahead and go through this, it's plus 1. Right. You will end up, if I add these together, you'll end up getting this the right answer either way. Because what I'll get is I'll get 3y equals negative 9. Solve, get y equals negative 3. You can plug that back in, solve for x. Whatever way works for you. Number 4, solve the systems of equations. Alright, so, again, if you want to do substitution, go for it. But in this problem, I'm noticing that I have a 3x on top, and I have a 1x down low. I want to get the same number, different signs. So I'm going to multiply the bottom one through by negative 3. Alright, off to the side here. The top equation stays the same. Okay, the bottom equation now, because I'm multiplying through by negative 3, becomes negative 3x minus 15y equals negative 15. If I add them together, the x's cancel out, jackpot. 4 minus 15 is negative 9. Oh, I'm sorry, negative 11, y, and this gives me negative 33. If I divide both sides by negative 11, y equals 3. Okay, now you pick either one of these. So right away I know I can do this. That's gone, that's gone. I'm going to pick the bottom equation, x plus 5y equals 5. Plug in 3 for y. This gives me 15. subtract 15 over x equals negative 10. So we're looking at negative 10 comma 3. They're all good. Okay? Cool. Armani is a woodworker. He makes cabinets either out of walnut or oak. He charges $300 for each walnut, and he charges $450 for each oak cabinet he sells. Last year he made 12 cabinets and sold them all for a total of $4,800. How many walnut cabinets did Armani make last year? Okay, this one we have to set something up. So here are my prices. $300 for walnut, 300x. We're going to call x number of walnut, and we'll call y number of oak. Alright, so 300x plus 450y equals 4,800 total. Well, they sold a grand total of 12 cabinets. X plus y equals 12. Okay, so we're looking to cancel something out here. I'm going to show you guys this on a separate piece of paper so I have some room to work with. Alright, so, oops, I'm covering up the problem. I can multiply this bottom equation through by negative 300. I'm trying to get something to match up. Up top, I have 300x plus 450y equals 4,800. Down low now, I get negative 300x minus 300y equals negative 3,600. Well, good news. This goes away. 450y minus 300y is 150y. 4,800 minus 3,600 gives me 1,200. If I do 1,200 divided by 150, I get y equals 8. Okay, well, let's take a look at this. Y is number of oak chestnuts. Okay, chestnuts, cabinets. Oak chestnuts. Okay. So, I want the number of walnuts. Well, if my equation is x plus y equals 12, alright, so x plus y equals 12, I know that y is 8, so I can solve for this and get x equals 4. I know that 4 is my number of cabinets that I can get. Alright, that's a lengthy problem, but nothing too crazy. Okay. Alright. Number 6. Solve the following equation for x. This one you guys should be cool with. We can distribute the 2 in. 8x minus 6 minus 8 equals 4 plus 2x. Let's combine like terms. The negative 6 and negative 8 are on the same side. So 8x minus 14 equals 4 plus 2x. Let's get all the x's on one side. I can subtract 2x over. 6x minus 14 equals 4. I can add 14 over. 6x equals 18. Divide by 6. X equals 3. Boom. You guys are definitely good with that. Okay? Very nice. Alicia, number 7, is solving the equation 5 plus 2x equals 8x minus 12. The first thing she does is rewrite the equation as shown below. Which property did Alicia use to get from the original equation to her rewritten equation? Alright, so here is her original equation. Alright, so how did she move this 5x over to the other side? Alright, well, she had to subtract 5x from both sides. My apologies, but the answers here, you needed to have subtractive property of equality. So basically, like whatever move you do, if I subtract, it's subtract. If I add, it's add. If I distribute, it's distribute. I think it was just a typo on my part, so my apologies. But we're looking at subtractive property of equality there, okay, or subtraction of property of equality. All right. On to the back. See if we can do one or two more here, and then we'll end this video. Actually, this is a good one to end on. Number 8. Dave spent $74 at the hardware store. He spent $6 on screws and $8.50 each on some deck boards. So $8.50 each, meaning that there's more than one of those. The equation below models the situation. What does X represent in this situation, or this equation? We are not even solving this problem. You're just trying to say, hey, what do these things stand for? So we're reading the problem. $74 is how much he spent. Okay. $6 and $8.50 is the cost, okay, of the screws and the cost of the deck board. So look at my answers. Right away I can cross off the cost of. So I'm down to X representing the number of screws or number of deck boards. Well, check out how it's $8.50 times X, right? $8.50 each on some deck boards. X just represents the number of deck boards. All you're doing there is playing like a detective and sleuthing around and get the correct answer. Okay? You're reading the problem, helping yourself out. So we are going to pause right here, and then the second video will pick up right here at number 9. As always, keep up the good work. All right? If you have any questions, please feel free to ask. But as always, good luck. We're all counting on you.